more problems on your note sheet that we started yesterday that we need to go over. There's still piecewise functions. Does anybody need another note sheet? Let's go ahead and graph these together. Now this is a piecewise function. In order to graph a piecewise function, we have to use what method? XYT chart. Remember, in an XYT chart, normally you can pick the values, but in a piecewise function, they give you the inequality, they give you the values that you can put in. So for the first t-chart, we can only pick values that are greater than or equal to 3. For the second t-chart, what can we pick? What's it say? Less than 3. Now the first number I have to put in on both of these is what? 3. Has to be 3. That's an endpoint. It has to be the first one we put in. So we'll put 3 in. What are some additional values that I could select that are greater than or equal to 3? Emily?
4, 5, 6.
4, 5, 6. Perfect. So let's put 3, 4, 5, and 6 in for x in our function. 3 plus 1 is 4. 4 plus 1 is 5. 5 plus 1. And 6 plus 1. We're ready to plot these on our graph. Now before we plot them, it may be beneficial for you to draw in that line. Remember that vertical line we drew yesterday? That really just separates, tells you there's going to be one graph on the left, one graph on the right. It's the only purpose. It's really not part of our graph, it's more of a visualization. So where's our vertical line going to be? 3 at 3. Go ahead and plot. When we plot that first point, that first endpoint, we'll use an open or closed circle.
Open.
Close.
It's closed. How do we know it's closed, guys? Equal to. If it's less than or equal to or greater than or equal to, we're going to use a closed circle. A filled-in circle means equal to. That's what it means. An open circle means there's a hole there. It means it's not equal to. So we need to use a closed circle at 3, 4. We have 4, 5, 5, 6, 6, 7. Go ahead and take your ruler and draw in your ray.
Or for an open circle.
What would it be? Less than?
Or
Greater than. Remember, an open circle means there's a hole in your graph.
So if with less than a greater sign of a line on here, it's closed and it doesn't.
Correct. Okay. For the second t-chart, we need to pick values that are less than 3. But what's the first one we have to put in? 3. Pick additional values that are less than 3, like 2, 1, and 0. Some of you are just kind of skipping around. I would try to make them go in order. That way we don't have any big gaps in our graph. It's easier to think about when we're graphing. So let's put 3, 2, 1, and 0 in for x. So negative 2 times 3. Negative 6. Put 2 in. Negative 2 times 2. Negative 4. Put 1 in. Negative 2 times 1. Negative 2. See, negative 2 times 0 is 0. Now when we put that first endpoint in our graph at 3, negative 6, we'll use an open or closed circle. Open. 3, negative 6 with an open circle. 2, negative 4. Negative 2, 0, 0. Remember, just that endpoint is open. Every additional point is closed.
that.
Like what?
Like how that one is open.
Well, if they were both closed circles, it wouldn't that's a vertical line.
How come all the other dots are open?
Yeah.
Okay, but that's a good question. Good question. If you look at the inequality is saying that that's for values less than 3, correct? Is 3 less than 3? No, that doesn't make that true. So that's why we have to use an open circle, because 3 is really not a solution for that graph. But every other number we select, like 2, 1, and 0, those are all numbers less than 3, right?
Yeah.
That's why we put an open circle there. It's a hole. It's really not. It's just a placeholder. It's not really part of our graph. How about the domain? What numbers could I put into X, Stephen? All numbers. In the first table, we were able to pick numbers that were greater than or equal to 0. The second table, we picked values that were less than 3. That takes care of everything, doesn't it? Numbers bigger than 3 and less than 3, that's everything. Now our range is our output. What numbers can we get out of this function?
Y is greater than -6.
Y is greater than -6. Could it be equal to -6?
No, because there's no point close to it.
Right. There's not a closed circle. If that had been a closed circle, then it would be greater than or equal to. We have an open circle.
I don't get how you get the range.
Okay. Do you agree that we have a lowest point on our graph?
Yeah.
Okay, which is at -6. You know, I've got -6. That's the y coordinate for that point. All these other y values, like -4, -2, 0, that would be 4, 5, 6, 7. All those values are greater than -6. So I just write and think that all my y values are greater than -6.
You get it now? I know it took me a minute to get it, but I figured it out.
Domain and range is one of those things that once you get it, you got it. You know what I mean? But it just takes a little bit sometimes to click. And keep asking questions. If you don't get it, I'll just try to re-explain it a different way. It will click, I promise. So we'll do a lot of this in Algebra 1 and do more of it in Algebra 2. It will click. And you'll see it again in college algebra. Huh?
Geometry.
Not domains or
You
ranges.
do pretty much shapes in there.
Lots of shapes, triangles.
Oh, triangles are.
I love triangles. More of a
So we have circles. We do circles in geometry. Really don't do circles in geometry. I'll talk for you.
I was talking about geometry. You use fingers.
Probably more.
Double up.
Alright, how about this last example? Let's do this one together. We have 2 pieces. Again, we're going to need 2 tables, X by T charts. You get to pick values for X, but they have to satisfy these inequalities. The first table, we need values that are less than 5. The second table, we need values greater than or equal to 5. So when we pick values, what's the first thing we have to pick? 5. Now pick some values that are less than 5.
2, 1, 0.
4, 3, 2.
That's not 0 would be easy.
That would be fine. You could do 2, 1, and 0. That's fine. As long as they're less than 5. Make sure you also have 5 in there. Alright, so put 5 in to this function. This is the opposite of x minus 2. So the opposite of 5 is -5. And -5 minus 2?
-7.
-7. Put 4 in. The opposite of 4 is -4 minus 2.
6.
Put 3 in. The opposite of 3, -3 minus 2. Put 2 in. The opposite of 2, minus 2, -4. Now when we plot these points, we'll use an open or closed circle at 5, -7.
Open.
Open, how do I know?
Because it doesn't have the equal to.
It doesn't have equal to, that's correct. I'm going to go ahead and draw my vertical line. Where will we draw the vertical line?
On 5.
At 5.
Use green as well. Well, she's yelling yesterday.
What if I did it this way instead of doing it this way? It's still the same one.
Well,
first point as an open circle, 5, -7. We have 4, -6. Remember, this is a ray, we have an endpoint and arrow going in one direction. We have a defined endpoint, find it. For the second table, we need to select values that are greater than or equal to 5. So the first value to put in is 5. Maybe 6, 7, and 8 would be good points to put in. So we're going to add 3. So put 5 in, 5 plus 3 is 8. Put 6 in, 6 plus 3 is 9. Put 7. That first endpoint of 5, 8, will that be an open or closed circle? Closed. Closed. Does your graph look like my graph? Okay, so let's identify the domain and range. Remember, domain is your input. What numbers could I put into this function? All real numbers. Our first t-chart deals with values less than 5. The second one's values greater than or equal to 5. Dawson, you have a range for me?
Y is greater than
Y is greater than -7. Tell us why. That's correct.
because all the Y values greater than 7
Greater than -7?
Next.
Our graph definitely has a lowest point. Agreed?
Yes.
At -7. All these other Y values, this one's at -6, this is -5, -4. Up here we have 8, we have 9, we have 10. All those Y coordinates are greater than -7. And
Will the closed circle always be above the open?
not always.
So Y is greater than.
In Algebra 1, the graphs are very nice and perfect. In Algebra 2, they won't be as perfect. And in fact, in Algebra 2, we don't see too many that are just two-piece functions. There'll be three-piece functions. Not a big deal. We'll just have, instead we'll have two rays going in different directions, and we'll have a segment in the middle. Not a big deal. I think that's all for the notes that I have for you. A couple of things I want to remind you of. Tomorrow, well, tonight, you're going to have 3 more problems to practice. I'll give you that in just a second. Tomorrow, I need you to turn in those 3 problems as well as your study guide. If you do tomorrow, your study guide. Tomorrow, we will review and we'll take a test when? Thursday.
We have a test at dance science.
Yeah.
I've already done it.
After your test, we will start reviewing for your final. So there's a good chance you're going to have some work to do after your test. Okay. We're at the end of the year, guys. We're going to cram as hard as we can to get you guys to score as good as well as you can on your final. Which is when? When's your final? A week from today. That's 1 week from today. We have to get ready for our final.
It's almost.
We've covered chapters 1, 2, 3, and 4. Now we're taking the test over chapter 4 right now, correct? Okay. So really, my focus for you guys is going to be on chapters 1, 2, and 3. Because we're just taking a test over 4. I do have a review sheet for 4, which I'll give you. But my main goal is to go back and review chapters 1, 2, and 3. Friday, and Monday. Okay? We can get 3 chapters done in 2 weeks. Addie. That's not a problem, not a problem at all. Let me go ahead and pass out today's problems. Do you guys feel better about this than you did
Yeah.
yesterday?
Yes.
Now, let me stop this video and then upload it. Hang on, let me upload this video and